Hello everyone, welcome to Vocabulary of Physics. In this video, we are going to discuss about correlation and causality. So this video will throw you into a lot of technical terminologies. So probably you will have to be much more cautious about it. Whatever we did already, they were fundamental concepts, but these are technical terms. Let's get into it. So first of all, correlation and causation. Causation is simply cause-effect relation, basically. So one causes the other. Let's say you have two events happening. A happens first and then B happens. A causes B to occur. Like you, for example, you eat something and because of that you get that vomiting sensation probably. So the eating something which is undesirable to your tummy causes that vomiting sensation. That's one example you can take it. Similarly, if you go for correlation, correlation is a little subtler, need not be only cause-effect relation. There is other possibility also. Either it is causation, like one causing the other, or both of them are caused by something else prior to this. So that's also another possibility. So let's understand them using an example. This is a fact that we know. When summer comes, ice cream sales go up. That's a fact. So if you understand it, is there any cause-effect relation? So summer comes, ice creams is going to be sold more. Yeah, that looks like a cause because of the increased temperature. People would like to eat something cold. So there is a causal relation. You can give a logical explanation to that. And of course, whenever you have a causal relation, obviously it is going to be correlated because correlated is a superset of causation there. Now let's take another example. When summer comes, shark attacks go up. That's also another fact, established fact, statistically observed. But if you observe it carefully, they may not look like direct causation. Summer creating shark attacks may not be direct causation. But if you give a roundabout logic, during summertime, people tend to go to beaches more often. So because of the increased population in the beaches and sea shores, so the sharks may be getting agitated because of that you have that attacks probably. So that way you can have indirect causation. Definitely there is a relation. And of course, whenever you have causation, you have correlation also. And another example, when ice cream sales go up, shark attacks go up. That looks like a very serious thing. Like see, ice cream, when you eat, you will be attacked by a shark. Otherwise, when you are attacked by the shark, ice cream will be eaten by you by something magically. So they don't look like cause-effect relation, definitely. But both of them are basically dependent on summer effect. Like so, both of them have a common cause. That is, summer is there, increased temperature in the atmosphere. That is a basic cause. So that way they are not cause to one another. One is not the cause to the other, but they are related because they have a common cause as well. So that's another idea. And now let us look at another example. This is also a fact, statistically established one. Last over 20 years, if you look at the information, that's what it says. Pirate activity goes up with rising global temperature. So that's actually seen to be correct there, happening really. But if you try to give explanation to it, it is going to be completely illogical. There is no logic to it. It might just happen coincidence, like by a chance. That's also possible. We don't call that it is causation or correlation. There is no correlation. There is no causation, but they can just happen like that. That's also a possibility. So if you put everything at one place here, you see summer causes the temperature to rise and that causes the ice cream sales to go up. Summer causes the people to push towards the beaches and that makes the shark attacks to go up. And these two are correlated, but they are not caused to one another. These two have a common cause, which is summer here. And if you look at the summer causing the shark attacks go up, that is going to be indirect causation. That's what we have been discussing about. So if you want to understand that like sets wise, say anything that are linked to you, you say that they may be correlated, they may not be correlated. The correlation could be spurious, like we have seen another example. Just by chance you can have it. So in that there is a certain set where certain things are correlated, some are not correlated, you can remove them. Within the correlation, you have two cases where they have a cause-effect relation, where they don't have cause-effect relation. So cause-effect relation is a subset of correlation and correlation is a subset of the next level that you have it. So that's a pictorial visualization you can have. Now, type of correlation, if you observe, there are two types of correlations. One is strong weak correlation, that is one thing. Just take some examples. age increases, wrinkles increase, very strong relation there. Exercise, heart health, smoking, lung cancer, they are very strongly correlated. But if you go for other cases like chocolate consumption increasing pimples there, it is seen that the study is true, but the link cannot be very strong there. It is not that much effect there. There is a mild effect, yes, definitely. Similarly, classical music increasing intelligence, it is statistically seen that it is true. There is a mild effect of classical music and the intelligence levels, but that's not very strongly correlated. Similarly, video games increasing violence, yes, it is there, but it is very mild. It's not like people become like zombies going on the road and killing people like that. That doesn't happen that way. So next, positive and negative correlation. You can also have that. So for example, if you look at it, when you go down into the ocean, more the depth, more is the pressure. But more the depth, lesser is the temperature. So when depth increases, pressure increases. That means they have a positive correlation. But when depth increases, temperature decreases. That means they have a negative correlation. Similarly, air pollution and respiratory illness both increase. But demand and price, if you look at it, when demand increases, price decreases, or demand decreases, price increases. They have inverse relation. That is what we are talking about. Otherwise, we call it as negative correlation there. Forest cover, when it increases, rainfalls increase. When age increases, running speed decreases. So they have a negative correlation there. So positive correlation as well as negative correlation. Both are there. Now let us look into causality a little more in detail. There are mainly three characteristics of causality. Number one, cause should come before the effect. Cause cannot be simultaneous to effect, or cause cannot come after the effect. So they have to come in the same order. Cause comes first, then the effect comes. This is called temporal order. Temporal meaning time related. Time, in terms of the time, cause comes first, then effect comes. So if you take an example, imagine that there are two events here, event A and event B. Event A is doing exercises and event B is your health becoming better. So the one which comes earlier is also called antecedent or precedent. So these are the words we use. The one which comes later as a result of this, that's called consequent. So antecedent or precedent comes first, and after that you have the consequent or the one which is the result that we are going to look at it. So the temporal gap has to be there. And again, whatever is happening, cause effect relation, it cannot be a magical one without any natural cause or natural process. You should be able to explain what was happening, why, because of this event, you are able to improve your exercises. If not, you, some experts would be able to give that explanation, that linking. So the linking has to be natural. It cannot be magical. That is another thing. So that's what we call it as mechanism. The next one is cause acts on something to trigger the effect, the triggering effect. Triggering effect is also very, very important. So there is an interaction, cause interacting with something. Because of that, it is triggering something. And because of that, this effect is coming. So that you should be able to give a logical explanation to that. Only then we have, this is called to be causality. So these three are important parameters which are required for a particular relation to be causal. So that's important. Causal fallacy, fallacy meaning false causal. They are not causal, but they appear to be causal on the first level. So if A and B occur with no time gap, there's no time gap there, then they cannot have a cause effect relation. So no time gap, we also call it as simultaneity. When two things happen simultaneously, they cannot be cause effect relation. For example, according to Newton's third law, you must be knowing, for every action there is equal and opposite reaction. So when the rocket is going up, the exhaust gases are pushed down. As a reaction to that, the rocket is pushed up. So the rocket goes up. That's the idea, you know it. But if you look at the reaction and action, they are not coming one after the other. They come simultaneously. They are generated by the excess pressure inside simultaneously. So they cannot be cause effect relation. Action causing reaction, reaction causing action. That is not true because they come simultaneously. Because of that simultaneity, you can't say that there is a cause effect relation between action and reaction. That is important one. And sometimes you may have a feeling like A happened first and after that B happened. So A should be the reason for B. So that may not be true. You need to be able to give that logical explanation as to why it happens. Other characteristics also should be taken care of. That's one. Otherwise, you say that it is a spurious or chance correlation. That's important one. And to avoid this kind of fallacies, generally we do a lot of analysis. It's a very long process, tedious process. It might take years to establish causal relations sometimes. So whenever you collect data, in that whatever chance, like spurious, not really having a logical connection to that, those things have to be eliminated. And after that, you go for confounded relations. Confounded meaning surprising or peculiar, or otherwise we call them as outliers. They are not supposed to happen, but sometimes they can happen because of various reasons. Because in reality, when things happen, the reason may not be linear. So whenever you identify certain peculiar things, those things have to be filtered out. Then you go for non-causal. Non-causal in the sense, if A happens, B happens. That's all right. If A doesn't happen, B should not happen. Then also if B happens, meaning this A is non-causal. So kind of things also should be filtered out. Finally, you'll be left with that causal relation. That's how we do that. This is the kind of research generally that goes on. So much harder to establish causality. It's very easy to disprove the causality, but proving the causality is a very difficult part. Now, types of causes. One is a necessary cause, meaning it is a must. Example, in physics, if you take it, work and kinetic energy. If you want to increase kinetic energy, only work has to be there. Only work can cause change in kinetic energy, nothing else in physics. So without work, kinetic energy cannot be changed. So there is a necessary cause there. But if you go for a hydroelectric power generation, electric power generation can be possible in terms of hydroelectric effect, all right, but that's not the only possibility. You can have alternative solutions. You can have thermoelectric generation, you can have nuclear generation, wind generation, solar generation. There are many others. So it's not compulsory that hydro is only required to produce electric. Hydro can produce electric. There is a cause effect relation, but that's not a compulsory. That's why we call it as sufficient cause. And after that, you can have multi-factor causes there. So in the sense, one thing to happen, there need to be certain things, a lot of things to be moved around together. For example, you want to run a car. For a car to run, there are many things that should happen before that. Maybe you need to press the pedal first, then the engine has to run, the fuel has to be injected into the combustion chamber. You must have the sufficient pressure for it to be burnt. And then whatever pressure comes, that should be able to push the piston. That piston movement has to be connected into rotating movement. And then the tire has to be on a gripping surface, not on the frictionless surface. There are many things that have to happen. So in fact, many times in reality, what happens is for something to happen, there could be many multiple causes that are supposed to be working together. That's also another important. Now, beyond the basics of causation, you can look at it as we have seen direct causation and indirect causation. We have already discussed. This is another important one, deterministic view and probabilistic causation. So what it says is that if I know what is supposed to be done now, if I understand my present and past, I can decide what is going to happen in future. Future is determined. There is no confusion about future. That is deterministic view. That's what we talk about in classical physics. But when you go for quantum mechanics, for the same set of present variables, present conditions, the outcome can be lot of possibilities. So probabilistic view we go for. But causation says that deterministic view. So that does it mean that quantum mechanical level, this causality does not work? That is another question. So should we modify the causation effect into a little more subtler way? That is another point that we need to work on. And effect of observer, this is very important here. Effect of observer on the causal effect is very important in quantum mechanics. Even at the regular level also, imagine you are studying. If someone is watching you, and then how you study. If someone is not there, they are sleeping and they have forgot to observe you, then how will you study? So your study pattern will change depending on whether you are being observed or not. So that's also another important factor that is not being taken care of already in the study of classical mechanics there. So that's important one. And then more philosophical way, if you go for free will and determinism, free will says that I can decide my future. Whatever my present and future, present and past, future can be decided depending on my how I work now, how I decided to continue with it. But determinism says that there's nothing you can do about your future. It's already decided based on your fate. What you did in your past karma and present situation, what is going to happen in future is going to be decided. So this is going to be a problem. But causality meaning probably it is going to aim towards the determinism. That's another aspect. So finally, I'm just listing out all the words that I had used in this particular video. Please have a look at them. These are the terms we have used. These terms are a bit technical, so please go through them and try to understand the meaning of them in the context of physics. They'll be very useful. Probably you can take a screenshot of it and try to understand that. So with that, I'll conclude here. Thank you very much for joining us. We'll get back to you soon with another interesting video. Until then, goodbye.